Vectors and conics, this is our last one, Friday, April 6th. Hopefully, with all the time that you guys have had the last couple of days, because the videos are only like 12 to 15 minutes, that you are looking back at this stuff and remembering how to do some of these, because your common assessment is Tuesday. Okay, that's next week. All right, so here's some things that you need to know. X is always equal to R. Anytime they give you an R and an angle, you can find X by taking R times cosine of theta. You can find Y by taking R sine theta. X squared plus Y squared equals R squared, so you also should know that R equals X squared plus Y squared. These are the same thing, just one square rooted. And you should always take arctan of Y over X to find theta. Adjust for quadrant. So write the component form for this vector. You have to know component form is tip minus tail. That's the end one minus the beginning. So this is the tip and this is the tail, the beginning one. So when you subtract, if you don't subtract in this order, you're going to get it wrong. You have to start with the second one, -4 minus 3. It does make a difference. And then 9 minus 1. So your answer is -7 and 8. That's it. Make sure you have the right symbols. If you don't have these symbols, you're going to get a point off. What is the magnitude and direction to the nearest tenth of -6, 8? Now this is component form. So -6, 8 somewhere up here. So it looks like that. So your magnitude is just 6 squared and 8 squared, which is 36 and 64, which is 100, which is 10. The angle, just for quadrant here, I'm not using negatives, is 8 over 6. It's the Y over X. So this is in the second quadrant. I am not using negatives. 53.13. So that's to the nearest tenth, so we'll go 53.1. And we're going to take 180 minus 53.1 to get 126.9. And that's your angle. That's your direction. Now, what's another way we could say this? You could also say 53.1 north of west. I would accept that as well. Write in component form. So the magnitude is 12 in the direction of 60. So it looks something like this. And they want you to tell me this one and this one. So if this is 60 and this is 12, you would go 12, that's your R, so X equals your R times your cosine of your angle. Oops, so that's 12 cosine of 60. The cosine of 60, hopefully you know, is 1/2. So that should be 6. And then Y is the magnitude times the sine of 60. So the sine of 60 is radical 3 over 2. So that's 6 radical 3. If you do it on the calculator, 12 times sine of 60, you get 10.4. It does say write in component form, so that would be 6 radical 3 with component form symbols, or 6 10.4 component symbols. Magnitude of 15, the direction of, this would be 15 cosine of 210, 15 sine of 210. Let's do it on the calculator first. 15 cosine of 210 is -12.99. I would go, should we go -13? What do you guys think? Let's go 99. It doesn't say about nearest tenth or anything. So that's that. And then sine, -7.5. So that's what it is in decimals. If you wanted to do the exact, cosine of 210 is negative radical 3 over 2, and this one's 1/2. So it'd be negative 15 radical 3 over 2, and this would be -7.5 still. That's exact. Identify each conic section. Only one square term, parabola. 2 squared terms, that's a plus, so it's not a hyperbola. So it's either an ellipse or a circle. It is an ellipse because the 14 is different than the 5. And then we have two squared terms, but we have the big old minus there, so that's automatically a hyperbola. Write the equation of the conic section. Okay. So it says foci are negative 2, 0, and 2, 0. So I know already that the ellipse has to go this way. And then it says one of the vertice numbers is 7. 3, 4, 5, 6, 7. So the vertice is going to go all the way out to 7. So it's going to look something like this. So we need to write the equation of it. So it's an ellipse that is in this form. Okay, so it looks like the center is 0, 0. So that automatically makes this happen. Okay, the A is 7, and it's going longer this way. It's under the X because of the foci points being on the X-axis. It needs to be longer this way, so that means the 49 is going to go here. 7 squared goes there. And then we're going to use our foci formula for ellipse. Since ellipse has a plus in the formula, it has the minus in the ellipse formula. So A squared is 49. C squared is, C is 2, right? C is 2 from here, center to foci is 2. So that is 4. So if I added B squared over here and subtracted 4 over here, this would be 45. And that goes there. That's your answer. Hyperbola, where the vertices are negative, I'm going to use this graph this time. Hyperbola, where the vertices are negative 3, 9. That's a vertice. It's not a foci, it's a vertice. And the other one's negative 3, negative 5. These are your vertices, so it's going to be opening like this. So already that means to me that we're going to be using this form. The A squared always goes with the positive term, and it's going with the Y's because it's going up and down. Because those are your vertices. Okay? So the center is in between these. So between 9 and negative 5, there's 14 units between there. So if you go 7 units, you should be right here at negative 3, 2. So the center should be negative 3, 2. So that means to me that this is going to be y minus 2 squared minus x plus 3 squared across the top. So I put the center in. The distance from here, center, to a vertice is 7. That's 7 and that's 7. That's A. So the A goes underneath the Y. Right there. So it tells me what C squared is. So the formula for foci for hyperbola is the plus sign. Since there's a minus here, it's a plus sign in the foci. So C squared is 53. It's telling me C squared is 53. A squared is 49. So B squared is 4. And that's it. A whole 8 minutes today. So if I was you, I'd start studying this stuff, and you guys have the rest of the day off. I'll see you guys Monday. Have a good weekend.